Good afternoon everyone and welcome to my YouTube channel. So we are looking at what we call the extraction of aluminium. So unlike these other extractions such as iron and other things, aluminium uses electrolysis. Now why does it use this method? So this is simply because of its position in the reactivity series. So you will realize to say the position of aluminium in the reactivity series, it is above carbon. Therefore, it cannot be reduced by carbon. So aluminium uses the method which we call electrolysis. Now the ore for aluminium is what we call bauxite, which is just aluminium oxide. So that is the ore. So if you have read your notes, you will realize to say that aluminium is quite reactive, therefore it tends to form very stable compounds. These stable compounds cannot easily be overcome by excess heat. Therefore, there is need for the boiling point of aluminium to be reduced by the addition of what we call cryolite. So this one is added to reduce the boiling point of aluminium. So with that brief thing, we can now start answering the question. So the first question says that the extraction of aluminium. The diagram below shows how aluminium is extracted in the industry. So we have this. So this is the diagram. So we have the notable things which are the graphite. As you can see, the graphite is positively charged, and the graphite, the cathode is negatively charged. The anode is positively charged. So that is the way the connection is. So now, the first thing that we need to look at is the first question, which says that name one ore from which aluminium is extracted. So with that one, the ore from which aluminium is extracted is what we call bauxite, which in chemical formula it is aluminium oxide with this chemical formula. So looking at the second one, which is our B says that why is aluminium oxide dissolved in cryolite? So it is dissolved to reduce the boiling point. Sorry, not to reduce the boiling point, but to reduce the melting point. So as you have seen, here there is what we call molten. So how do we create something that is molten? By applying enough heat so that it can be turned into a liquid. So molten means a liquid that is made as a result of excess heat. So this is done to reduce the melting point of this substance. So looking at C, we are told to say which electrode has to be frequently replaced during the process. So the electrodes that they are talking about are simply the anodes and the cathodes. So one of these has to be frequently replaced. So when looking at the electrodes, we are going to find that the graphite, as you can see here, there is the accumulation of oxygen. So graphite, as you know, its nature is made up of carbon. So carbon is able to react with oxygen to form carbon dioxide, of which the graphite anode will be able to more like evaporate since it is being converted to a gas. So it has to be frequently replaced so that such a situation does not take place. So to answer our C, which says that which electrode has to be frequently replaced during the process, here we are just going to say the anode, or we can say the graphite anode. So there is a question attached to it. Explain your answer. So the simple reason is that to avoid So it is simply to avoid evaporation of carbon dioxide. So as you may know, when oxygen reacts with the graphite, which is just a type of carbon, it will be able to be converted into carbon dioxide, which can evaporate. So due to that, to prevent that, they have to be frequently replaced. So the graphite anode, so this is done to avoid evaporation of the carbon dioxide. So as the carbon dioxide evaporates, remember the carbon dioxide is coming from this graphite. It means to say the graphite anode will start eating away because of the conversion of this solid thing to a gas, which can easily evaporate. So if you ask such a question, that's the answer. Then at D we are told write the equations taking place at the anode and the cathode. So here we apply our knowledge on electrolysis or electrochemistry. So how do we answer such a question? So at first we need to identify. So we have at the anode. So we know to say at the anode what is taking place is that there is oxidation. So simply what will be there is oxidation. So now when this aluminium oxide is dissolved, it splits into its ions. So therefore, at the anode, what will be going there is what we call oxygen, which is our gas with the state symbol of 2 negative. So this oxygen will migrate at the anode. So now, since it's a non-metal of which it has got this, for it to become a gas, it needs to lose the excess electrons that it has in order for it to be at the original position. So we are going to say oxygen will become oxygen gas, provided that the 2 electrons are lost. So we are going to balance our equation like that. So this reaction is what takes place at the anode. Then if you look at the cathode, so as you know, the principle is simply because this is it's negatively charged, the positive ions will be able to migrate to this. So we are going to say at the cathode, the reaction that would be taking place is simply at the cathode, we are going to find that the aluminium which we want to extract is the one that will migrate there, because aluminium ion is positively charged. So we are going to say aluminium, which is just Al. Now the charge of aluminium, it is 3 positive. So for aluminium, which is a metal ion, for it to become a neutral metal again, it needs to gain electrons. Since we are looking at this, so it has got an excess of protons. So for it to reverse to its original form, it needs to gain electrons so that the protons and the electrons can cancel themselves. So we are going to say plus, we are going to have an electron should be able to produce aluminium, a metal like that. Now this metal, due to excess heat, it will be in liquid form. So we are going to have, since there are 3 protons, the addition of 3 electrons will cause the number of protons and the electrons to cancel themselves. So that is how we approach such type of equation. But we are not done. Looking at the next one, it says that aluminium is used in making pots because it is a good conductor of heat and light. Give another property of aluminium that makes it suitable for making pots. So as you have seen, they have already given us one point which is already known to most of us. So now, how do you approach such a question? So if you look at your reactivity series, you will identify to say aluminium is very reactive, but why then is it used in making pots? So the reason is simple. Immediately aluminium is extracted, it is coated with an oxygen layer which prevents further reaction. So if you ask the different question to say, why is aluminium considered to be unreactive? It is because once it is extracted, it it is easily coated with an oxygen layer, which prevents further reaction. So aluminium is used in making pots because it is a good conductor. Give another property that makes it good for making pots. So the reason is simple. So that's the property. So immediately aluminium is extracted, it is, due to its reactivity, it is coated with an oxygen layer, or in other terms we can say it reacts with oxygen to form a coating on it. That coat makes it unreactive. So due to that, aluminium is used in making pots. So thank you very much for watching my tutorial. I hope you would like and subscribe for more.